So we've sold over $1 million of AI solutions over the last few years, but here's the truth. I've never actually had a crystal clear understanding of how large language models actually work. And that gap is kind of concerning, especially if you're running an AI business. So good thing here is that we're here with my wife, who's the proper AI engineer. And we're going to be breaking down this tutorial, understanding what large language models are. Because fundamentally, if you want to build or sell or learn anything serious with AI, you cannot afford to misunderstand the foundations. Let's get straight into it.
GPT, or Generative Pre-trained Transformer, is a large language model, or an LLM.
What is a large language model in simple English, please?
So a large language model, it's just basically a piece of software that's read a huge amount of like text, books, articles, everything on the internet, code, conversations, and it's read all of that stuff and put patterns together and understands that you say, I feed my dog treats, for example.
Is there a small language model?
Just a language model is just something that has read a lot of information about something.
So is it like Spanish?
No, Spanish is a language.
But it's a large language model. No? Okay, cool. Sorry. I'm confusing the AI. That's AI. So,
it's not a language. A language would be something like Spanish.
Okay.
A large language model, an LLM, is a piece of software.
Okay.
Yeah.
Cool.
Not a language, a piece of software that's just read a lot of information, so it knows, has a crazy amount of knowledge, and it's taken all that knowledge, figured out patterns between them, and then uses those patterns to predict.
So it's like an encyclopedia.
It's an encyclopedia that can be like, what words tend to go together?
So it's a thinking encyclopedia.
Kinda, yeah. It has like logical reasoning. So it's like, hey, what sounds do cat make? What sound does a cat make?
And then it will tell you, oh, okay.
Meow. Think of it like, your autocomplete on your phone, where it like comes up with words that comes up next.
And it predicts the
next word. So it's like autocomplete. And we've had autocomplete for years, so it's like kind of like that.
Cool. Next.
Human-like text. And I've been using GPT in its various forms for years. In this video, we are going to, number one, ask what is an LLM. Number two, we are going to describe how they work. And then number three, we're going to ask what are the business applications of LLMs. So let's start with number one. What is a large language model? Well, a large language model is an instance of something else called a foundation model.
What's the difference?
So I think it's probably going to go through it. But the foundation model is kind of like a really, really big general purpose AI model. So it's still an LLM, so it's still a large language model, but it's trained on like super broad things, trying to understand patterns in general. Whereas an LLM, like ChatGPT, for example, are trained on like specific parts of it. So it's the foundation model is like a big broad category, so it's a big one, and then the LLM is like a foundation that's specifically focused on like language and text-like things, for example, like code or images or audio, that kind of thing.
Okay, cool. So foundation is the big one, LLM is the smaller one, but it's
like niche
large.
specific.
Niche specific. Okay, cool. I get that.
Now, foundation models are pre-trained on large amounts of unlabeled and
Yeah, I would not have understood that.
supervised data, meaning the model learns from patterns in the data in a way that produces generalizable and adaptable output. And large language models are instances of foundation models applied specifically to text and text-like things. I'm talking about things like code.
Got it?
Not really. Can you use an analogy or something?
Okay, so foundation model can have anything like images, audio, video.
Yeah.
A large language model is going to be something like text-based. So GPT was just an LLM.
Yeah.
And then it became an image generator too, right?
Yeah.
An LLM is just text-based, or like something that looks like text. So like code is just written, right? It's not an image.
Yeah.
So that's an LLM. Foundation model will have all of them.
All of them. Oh, I see.
Okay, tell me what you think. What does unlabeled data mean?
Like there's no tags or something associated with that data.
Right. So it's like you've got a really big unorganized drawer of things.
Yeah.
That are not labeled. You don't know what's what.
Okay.
right? And then you've got self-supervised data, which is when
Someone looks at it?
you've gone yourself and organized your drawer.
Oh, okay.
So traditional machine learning models, you'd have your big drawer full of all these different pens, and you don't know which one's which and which one's even working, blah, 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 blah.
Yeah.
If that was your drawer, I could come in, so the human would come in and say, this is a biro, this is a felt pen, this is a whatever. And then you'd be like, oh, okay, so that's what a biro looks like. That's what a felt pen looks like. That's what a crayon looks like.
Okay.
But the cool thing about self-supervised learning, which is what we do with LLMs, is that you will be reading lots of stuff and you'll have lots of knowledge about what a pen is, what a crayon is. So you will go into your drawer and label it. I don't go into your drawer and label it.
Oh, I see. Okay.
So self-supervised learning is,
I go into the drawer.
yeah, so you will have a lot of data that you know, a lot of knowledge that you know, and then you can kind of go in and predict and guess, this is most probably going to be a crayon
Got it.
because I know all this stuff. Whereas in traditional machine learning, you would have no idea.
No.
You would be like, what's a crayon? What's not a crayon? I would have to go in and be like, these are crayons, these are felt pens. And then you would be like, okay, that's a crayon, that's a felt pen.
Sweet. Clear.
Make sense?
Makes sense.
Now, large language models are trained on large data sets of text, such as books, articles, and conversations. And look, when we say large, these models can be tens of gigabytes in size and trained on enormous amounts of text data. We're talking potentially petabytes of data here. So to put
What's a petabyte? And why should I care that it's been trained on petabytes of data? What does that actually mean for me?
Okay, so you probably heard of
I've heard of gigabytes.
gigabytes. Okay,
Yeah.
you've heard of like
Megabytes, yeah.
It's kilo. Have you heard of K?
Minibytes.
KB? Yeah, so it's like K, then it goes to megabytes, then it goes to gigabytes.
Okay.
Then it goes to
Petabytes.
terabytes. Anyway, basically, you're getting huge amounts of data. Like petabyte is something that we don't talk about that often. You talk mostly in gigabytes, right? And megabytes.
Yeah.
Or terabytes, for example. You're like, oh, I've got a 1 terabyte hard drive. That's huge. So imagine a petabyte is bigger than that. And that huge amount of data means that it's seen, like the model itself has seen so many like styles of writing, topics, domains, what's good text, what's bad text. Yeah, lots of different languages, lots of edge cases. I mean, it's got such a huge amount of storage that it translates basically into like lots of broad knowledge, like pretty robust because it's had so many of like, so it's like, hey, this is what a good sentence looks like my cat eats food. And it's had like hundreds of thousands of my cat eats food. So it's super confident that my cat eats food is correct.
Got it.
You know what I mean?
Got it.
And yeah, that's how it's very good at adapting as well, because it's heard so many different writing styles. So that's when, if you're like, make this sound more casual, it's got so many ideas of what casual language looks like. So that it could be like, okay, yeah, I know how to make it more casual. We simply just go, make this sound better, make this sound more professional. But how does it know? It's because it's got such a huge amount of data, and that's why it's so useful for you. And the cool thing is we don't have to pay for, we pay a very, very tiny amount for something like ChatGPT, when it actually is a super, super expensive thing to run. So it's, it's kind of economies at scale. So it's just that so many people are using it, so many people are paying for it, that kind of makes sense.
Makes sense. Got it.
But it's a very, very expensive thing because it's hard to train something to be that accurate without having a lot of data and computing power.
Sweet.
put that into perspective, a text file that is, let's say, 1 gigabyte in size, that can store about 178 million words. A lot of words just in 1 GB. And how many gigabytes are in a petabyte?
100.
Well, it's about 1 million. Yeah, that's truly a lot of text. Now, LLMs are also among the biggest models when it comes to parameter count. A parameter is a value the model can change independently as it learns, and the more parameters a model has, the more complex it can be. GPT-3, for example, is pre-trained on a corpus of actually 45 terabytes of data, and it uses 175 billion ML parameters.
What is a parameter? And what is the no? I'm serious. Like what is a parameter?
So parameter is something that's adjustable, that you can go in and you can adjust it.
Yeah.
It's like, hard coding. Okay, you wouldn't know this, but like
Just so I just
It's like, you say hi first name,
yeah.
or you say hi Orion, and everybody gets hi Orion.
I'm
But
Orion.
but instead, when you say hi first name, it can be so many different things. So imagine that's one parameter, first name.
Wow, that's a lot of parameters.
So they've got 175 billion
Billy.
parameters
Billion.
in ChatGPT 3, and we're now at ChatGPT 5, so you can imagine. So basically, it just means there's so many different places that you can make little tweaks. So you can really fine tune, and like the more parameters, the more like dials the model can tune.
Got it.
So the more you can tune, the more like nuance, the more patterns, and the more like subtle changes that it can understand in languages. And that's why it can have capacity for understanding and generating such complex
Stuff.
Yeah.
Yeah.
So we don't manage these parameters, but they just tell you how rich and capable the model can be.
Nice. Just want to say, like, it's not in the video, but like, it's so cool to finally try and speak your language, considering we've been dating for we did it for 5 years and just got married. Like, it's nice to try and understand you a little bit more.
Yeah, he's not really tried over the last 6 years.
Yeah, I've not tried it over the last 6 years. So like now I'm learning parameters and large language models and foundational models.
Okay, tell me what's the difference between a foundational model and an LLM?
That's put it in the comments, guys. What is the difference?
Go on.
Well, we'll ask you at the end.
All right, so how do they work? Well, we can think of it like this. LLM equals three things: data, architecture, and lastly, we can think of it as training. Those three things are really the components of an LLM. Now, we've already discussed the enormous amounts of text data that goes into these things. As for the architecture, this is a neural network, and for GPT, that is a transformer.
What? What's a neural network and a transformer?
So it's kind of all of those little teams in your head that you have for like reasoning.
Okay.
You've got like,
The crazy head.
just imagine like Inside Out. And
Inside
there's
Out.
like, if you watch Inside Out the movie, and in your head you've got like all these different people that have different emotions.
Did you guys pick up on that?
Sure did.
Link in the comment on the movie.
Okay, Inside Out. Imagine you've got loads of little teams in your head
Yeah.
that are working on different things to try and help you come out with sentences or move your arms, move your legs, whatever it is.
Emotions.
Emotions, yes, for some of us. But yeah, for an LLM, this is like lots of different groups of people. They're not actually people though. Just imagine them as like little workers that there's a team for context, there's a team for knowledge, there's a team for
Learning.
or like all these different
Reading.
like there's so many different parts of generating a word that you need, and you need someone to evaluate it, QA, like all the different teams that you would need to go from context and understanding, reasoning, logic, all the way pattern recognition. Hey, let's look at all of this big data cloud that you've got and pick the right relevant things that someone needs to go do that. Well, not someone, but somebody in this little hypothetical team.
Isn't that your brain?
Yeah,
Oh.
but ChatGPT needs a brain.
Oh. What word is this again?
Architecture.
Architecture.
Neural networks. And
Neural
transformers.
networks.
And transformer is just the literal thing that it
Like
uses.
it transforms it. Or is it natural?
It's also like you've done physics.
That was like 10 years ago, guys.
And the transformer architecture enables the model to
Transformer architecture?
Yeah. So that's your neural network. What we just talked about.
Got it.
handle sequences of data like sentences or lines of code. And transformers are designed to understand the context of each word in a sentence by considering it in relation to every other word.
Right. So transform. It's like what you said, right? It's like going. It comes in as one thing, it gets transformed and comes out as something else.
Okay.
So it's all those little teams inside that need to do that transformation. So it needs to understand the words that came in. It needs to figure out what it is you're asking. Look at all of its knowledge from the knowledge and the conversation that you're having.
Got it.
Decide what should come next and then come out with your output.
Sweet.
This allows the model to build a comprehensive understanding of the sentence structure and the meaning of the words within it. And then this architecture
There'll be, a little something that looks at structure, the grammar, something that looks at the actual knowledge, something that looks at QAing it, fact checking it, that kind of thing.
Architecture is trained on all of this large amount of data. Now, during training, the model learns to predict the next word in a sentence. So the sky is, it starts off with a random guess. The sky is bug.
Huh?
But with each iteration, the model adjusts its internal parameters to reduce the difference between its predictions and the actual outcomes. And the model keeps doing this, gradually improving its word predictions until it can reliably generate coherent sentences. Forget about.
If it just predicts the next word, how is it doing sort of reasoning, advice, strategy, coaching?
So like, how does it make something intelligent?
Yeah.
Okay. Just because, again, it's seen in this huge amount of data, so many examples of how humans do it. So I know you might think it, but every time you ask a question,
Someone's
it's
asked
not
it.
unique.
What?
Someone has probably asked it before. So what it can do is it can search and be like, hey, this question's been asked all these many times. In all the times it's been asked, what's consistent about its response? So it may seem and feel intelligent, but it actually is just hugely knowledgeable and understands the patterns of what's happened before. So make something that is likely and very, very likely to be correct. But that's also why it's very, very confident in being wrong. Got it? Because it fits its pattern. So it's gone and it's searched every single time someone's asked what the color of the sky is.
It will just, yeah.
Yeah.
Okay, sweet.
Bug. You can figure out it's blue. Now, the model can be fine-tuned on a smaller, more specific data set. Here, the model refines its understanding to be able to perform this specific task more accurately. Fine-tuning is what allows a general language model to become an expert at a specific task.
Yeah, like when it says fine tuning, like what does that? Is it like fine tuning a guitar? You know, what does that mean?
Okay, so you've got, this big ChatGPT model that's been trained on crazy amounts of data, but it doesn't know a lot about you. It knows a lot about general things.
Yeah.
It knows a lot about the world as a whole. It doesn't necessarily know something that's quite specific. So if, we're talking business here, then it's taking that general model and then it's telling it specific things just about you and your business and what you support and your products so that it kind of becomes a specialist, right? Yeah, it's like becoming a professional at something specific. So it's telling it, what is it that you do? What are your products? What price point are you at? All of these things so that it can, if we're talking about a support agent, an AI support agent, it needs to know what it is that you do and what the general answers to those support questions are so that then it can learn from that specific little section of knowledge that right now is actually in your brain. So you just need to get out of your brain and put it somewhere and then teach it to somebody else. So imagine that you're teaching one of your VAs or you're teaching a staff member what you would want it to say. You just need to teach it in the same way. So you need to teach it about you specifically. That's what fine-tuning is. Or what you want it to achieve.
Cool.
Okay, so how does this all fit into number 3, business applications? Well, for customer service applications, businesses can use LLMs to create intelligent chatbots that can handle a variety of customer queries, freeing up human agents for more complex issues. Another good field, content creation. That can benefit from LLMs, which can help generate articles, emails, social media posts, and even YouTube video scripts. There's an idea. Now, LLMs can...
This guy's so British. So it seems like this can help in a lot of domains. Where, this is more of a personal question, where do you think you've used it the most in being a software engineer and also working with us and making $1 million online?
I use it a lot for repetitive tasks, mostly. So things that I could teach someone to do. It's kind of like writing out your own SOP and then giving it to somebody. It doesn't require too much. I mean, it requires some thinking, but kind of within some parameters, if that makes sense. So yeah, I use it mostly for repetitive tasks that I could be like step 1, step 2, step 3. And if I can say that out loud, it means the computer can do it too. Especially now when it can, generate all these things like they just talked about, like make blog posts, make your scripts, make your things like that. So if you just give it, you don't have to give it once, but you give a really good context about who it is, what your tone wants to be, who you're trying to serve, about you, like about your business, about your product, and in like the coding world, like what you're trying to achieve in the code, and maybe the rough areas of where it should should look. Kind of handhold it a little bit sometimes at the beginning, and then once it knows, it's just so lovely to be able to be like, hey, remember what I talked about? Yeah, let's go do another one of those. Let's generate me another script. But it already knows all of those things before, so it's really worth it to fine tune beforehand, and then you can just use it over and over again, and you don't have to keep telling it every single time what you want it to do.
Nice.
Even contribute to software development. And they can do that by helping to generate and review code. And look,
So
that's
helpful.
just scratching the surface. As large language models continue to evolve, we're bound to discover more innovative applications.
Just on that coding note, like, you don't need to be a developer anymore to be a developer. So I use it so much when developing. I literally just say, hey, I want to do this. I mean, it's useful that I understand the code because it means I can just go in and fix things when it hallucinates and makes errors. But the way that you see like Lovable and Replit and all of this generative code, it's just, you don't even need to write code yourself anymore because the LLM itself can generate your code, spot your bugs, review your code, write your tests, write all your documentation. So it just speeds up that process so much, and you don't need to be technical anymore. You just need to understand what it is that you want and be able to say what you want in a way that it understands.
So that's the real skill. So the real skill now is not necessarily producing the result, but actually refining the input and then reviewing the output.
Yeah, and you can waste a lot of time on AI. Sometimes it's like, is it worth speaking to it because I could have just done it myself faster?
Yeah,
but that's not actually an issue with the AI. What's it an issue with?
Humans?
The issue is what you put in. What you put in is what you're going to get out.
Yeah.
So if you put in something that's bad,
Poo.
you're going to get something out that's bad.
Poo.
It's worth giving an extra minute or two to write a really good prompt
Good.
so that you get something out that's really actually useful.
Good.
So, yeah.
Sweet. That was it. So what did we learn, guys? We learned a great deal about LLMs. We learned a great deal about what these things called parameters are and foundational models. Fancy words for...
Tell me what the difference is between an LLM and a foundational model.
A foundational model is a big AI, and a large language model is a smaller, more niche-specific AI.
Sure.
Cool.
Text-based.
Text-based. All right, you get my point, guys. You watched the video. Thank you so much for watching. This was us overviewing what LLMs are. Again, if you want any additional resources or sort of access to us and access to our training, there'll be a link in the description. And check this video out next. It'll be up on the screen. It'll be something
For more
about...
of this?
Yeah, for more of this stuff. So, peace and love. Thanks for watching.